Okay, so the question says find the diameter of a wheel that makes 113 revolutions to go 2 kilometer and 26 decameters. Okay, so there is a wheel. Okay, it has to take revolutions. So if we see one revolution, if we see the distance covered in one revolution, so distance covered in one revolution is equal to distance covered in one revolution is equal to actually the circumference of the circle, because in one revolution it will complete one complete circumference. So that is the distance traveled in one revolution by a circle is thus it equal to its circumference, which is nothing but 2 pi r. Now here he has taken 113 revolutions to cover 2 kilometer 26 decameters. So the distance covered in one revolution will be obviously the total distance, that is 2 kilometer plus 26 decameter divided by 13. Okay, so if we solve this further, this comes out to be 2260 meters divided by 13 because a decameter has 10 meters. So 2 kilometer and 226 decameter is actually equal to 2260 meters divided by 13, which makes it equal to 20 meters. So actually in one revolution the wheel is covering 20 meter, and we know that in one revolution it actually covers the circumference. So we can easily say that circumference of the circle is equal to 20 meter. Using this we are supposed to find out diameter. So diameter, let us find out the radius first. The radius value is coming out to be 20 divided by 2 pi. We have to find the diameter. So diameter is nothing but twice of radius. So if we do multiplied by 2, this is going to be 20 divided by 2 pi into 2. So the value comes out to be 20 by pi, which is 20 by pi. Pi value is 22 by 7. So it's going to be 20 divided by 22 by 7, which is nothing but 20 into 7 by 22. That is nothing but 140 divided by 22. If in the mixed fraction it is seen, it comes out to be equal to 64 by 11. So that is the right answer. 64 by 11 meter is the diameter of the circle that is available in option number C. So becomes the right answer. The length of a rectangle is decreased by r% and breadth is increased by r plus 5%. If the area of the rectangle is unaltered, that is the area is not changed, then find the value of r. Okay, so by doing these changes in the length and breadth, he's saying the area still remains same. So let us assume, let's say the length of the rectangle is L, let's say the breadth of the rectangle is B. He says let us find out the original area. Original area is always length into breadth, so original area is LB. Now let's see the changed length. Now the new length is going to be, he says that length is decreased by r%. So if the length is decreased by r%, old length was L minus r% of L. This should be the new length, which is equal to L minus r% of L. If you want to do, it is equal to 100 minus r over 100. 100 minus r over 100 into L, that is the new length. Similarly, he talks about new breadth. New breadth is becoming how much? New breadth, he says, is increased by r plus 5%. So it has to be old breadth plus r plus 5% of the old breadth. If we solve this expression further, this actually comes out to be 100 plus r plus 5 divided by 100 times the breadth. This is going to be the new breadth. Okay, now he says the new area is still unaltered, that is the new area is equal to old area only. So let us find out the area with new length and new breadth. The area is always length into breadth, so new area is 100 minus r over 100 into L into the breadth part is 100 plus r plus 5 divided by 100 into B is actually equal to L into B, because it is not changed. So clearly L and B gets cancelled from both the sides, so we are left out with 100 minus R over 100 into 100 plus R plus 5 by 100 is equal to 1. If we solve this further, we can clearly create an equation out of it. So it is 10,500 minus 105R plus 100R square plus 100 plus r square is equal to 10,000 on the right hand side. If we make an equation, the equation comes out to be r square plus 5r minus 500 is equal to 0. Doing the factor of this equation, we are getting the 2 factor r plus 25 and r minus 20 is equal to 0. Clearly, r cannot be negative, so r value can only be 20. So that is what is the radius. Let us see where it is available. It will available in option number A, so becomes the right answer. That is the right answer. Okay, so the question says the perimeter of a right angle triangle is 60 centimeter. Its hypotenuse is 26 centimeter. What is the area of this triangle? So let's create a right angle triangle. This is a right angle triangle. Let's say the 90 degrees here. A, B, and C. He says the perimeter is 60 centimeter. That means the sum of the sides is 60 centimeter. Okay. Its hypotenuse is 26 centimeter. So this value is given out to be 26 centimeter to us. Okay. Now he wants us to calculate, in using this, he wants to calculate the area. Okay. Now let us start doing this question by assuming any of the sides between base and perpendicular, because uh, base and perpendicular, because hypotenuse is already given. So let's say the base of this triangle is x. Okay, let's say the base of this right triangle is x. So let us mark the base here. This is x. Then what should be the height? Rather, what should be the perpendicular, or what should be the height? Okay, we can calculate this. The total parameter is 60. Total parameter minus the hypotenuse, okay, and minus the base, that will be equal to the height. Okay, because perimeter is the sum of all sides. If from sum of all sides we remove the hypotenuse and the base, we're going to get to the third side, that is AB. So this is coming out to be 34 minus x. So this is what is the height, which is here 34 minus x. Let us mark it here. Now these are the three things we have got. Now clearly we can apply the Pythagoras theorem, because it is a right triangle triangle. So clearly the Pythagoras theorem can be applied, which says hypotenuse square is equal to base square plus perpendicular square. Okay, here the hypotenuse square is 26 square is equal to base is x square plus 34 minus x whole square. Let us solve this equation further. If we do this, this is going to be 26 square is nothing but 676 is equal to x square plus 34 square is 1156. This can be treated as a minus b whole square, a square, that is 1156, plus b square x square minus 2ab. 2 into 34 is 68x. Okay, let us solve this further. So ultimately, by after solving this particular thing becomes a particular equation, that is x square minus 34x plus 240 equal to 0. So this is what is the equation that is being made after that. If we try to solve this using Sridharacharya or some other prime factorization methods, clearly this equation can be broken down into different factors as x minus 24 and x minus 10 equal to 0, which are giving x value as 24 and 10. Okay, so two value of x can be taken, either 24 or 10. So if the x value is taken as 24, then the height value will be 34 minus x, that is 10. And if x value is taken as 10, the height value will be 34 minus 10, that is 24. So anyhow, base and perpendicular can take any values between 34 and 10. So let us assume x base is 10 and the height value is 24. Now he wants us to calculate the area. So there is a formula for a right triangle a triangle area, that is half of base into height. Okay, so we can use anything. So a is equal to half of base value is 10 and height value is 24. If we solve this further, this comes out to be 120 centimeter square. So that is what is going to be the area of the triangle, available in option number C. Now, the parallel sides of a field which is in the shape of a trapezium are 20 meter and 41 meter. So let's make a trapezium. Okay, this is how the trapezium looks like. Two sides are parallel to each other. Rest two sides can be of different dimensions. So let's say these are the two parallel sides. Let's name this particular trapezium also, give it some shape. So let's say this is A, B, this is C, and this is D. Okay, let's drop a perpendicular here so that the height can be created of this trapezium. So this is a perpendicular. Let's say it is meeting at point E. Okay, then we can join. So these two have to get the parallel line. So let us join C with the baseline, make joining it at F. Okay, so what else is given to us? The parallel side of it, which is for trapezium, is 20 meter and 41 meters. So let's say the shorter one is 20 and the longer one from here to here is 41 meters. Then he says, and the remaining two sides are 10 meter and 17. So this is the remaining one. This is 10. So this side should be 17 meter. Okay, if this is 10, then obviously CF is made equal to in the same shade and parallel to this also. So this is also 10. Now, he wants us to calculate the cost of leveling the field at the rate of rupees 30 per meter square. So clearly, we'll have to find out the area of this trapezium first, then only we can find out the cost at the rate of rupees 30 per meter square. This is what is the strategy. Now, let us look at the triangle BCF. If we see the triangle BCF, okay, why we are finding out the height? Because the formula of the trapezium, the area of the formula of the trapezium will be half of sum of parallel sides into height. So we need we have got the parallel side sum, but we need the height of this trapezium. So for that, we have to do this construction. That is, the triangle has been created to find out the height. So if you see the triangle BCF, in triangle BCF, we can clearly say that three sides are already there. So this AF is obviously 20. So this FB is just 21. So this is the triangle that we can see. We can redraw it here. The triangle is here. 17 is this side, 10 is this side, and 21 is this side. In this triangle, we are using the Heron's formula for finding out the area. In the Heron's formula, we are supposed to calculate the S first, that is sum of all the sides, A plus B plus C divided by 2. So the sides are 10 plus 17 plus 21 divided by 2, which is coming out to be 24 meters. So that is the S value. Then the Heron's formula of area says, area is equal to under root of S into S minus A, S minus B, S minus C, where this A, B, C are the sides of the triangle. So let us find out the area. S value has come out to be 24. So it's going to be 24 into 24 minus 10, 24 minus 17, and 24 minus 21. These are the three sets that are there. Let us solve it. A is equal to under root of 24 into 14 into 3 into 7. These are the values. By doing the factors, we can find out the under root of this. So 24 can be written as 2 cube into 3. Then this 3, 1 3 is from here, 1 3 is from 24 power. So it can be written as 3 square into 7 square into 2. Okay, 2 2 2 to 2 power 4. This is how it can be written as. So if we take the power out of it, then the area is actually equal to 84 meters square. So this is what is the area coming, 84 meters square. Now, if area is there, so we can obviously find out the height. The another formula for finding out the triangle's area was half of base into height. So we can easily equate half of the base value can be taken as 21 into height value is unknown is equal to 84 meters square. We have equated this area. This will give us the height value. So by using this, the height value can be calculated. The height is coming out to be half of base into height. Height is coming out to be 8 meter. This height is nothing but the length of CE. Now we have got the height of the trapezium. We have got the parallel side length of the parallel side also. So clearly we can apply the formula of area of trapezium. The area of trapezium can be calculated by the formula is area of a trapezium is nothing but half of sum of parallel sides into height. Sum of parallel sides into height. So we have got the parallel sides length. So it is going to be half of 41 plus 20 into height. How much is the height? We just calculated the height to be 8. So if we solve this comes out to be 61 into 4, that is 244 meters square. That is the area coming. He has asked find the cost of leveling the trapezium at the cost of 30 rupees per meter square. So for 1 meter square, the cost is 30 rupees. So how much will be the cost for 244 meter square? So clearly it is a unitary method based question, that is 244 into 30, which is coming out to be equal to 244 into 30 is rupees 7,320 rupees. So this is what is the cost of leveling the trapezium. Let's see where it is available. 7,320. It is available in option number C, becomes the right answer. Now, if area of a square is equal to the area of a rectangle 6.4 meter long and 2.5 meter wide, then each side of the square measures. Okay, what he says, area of a square is equal to, so let's say we can assume the side of the square to be A, or rather we can first find the rectangle's area. What is the rectangle's area? The formula for rectangle's area is nothing but length into breadth. How much is the length given to us? It's given to us as 6.4. How much is the breadth? Is 2.5. So if you multiply 6.4 into 2.5, it comes out to be 16 square meter. So that is what is the area of the rectangle. He says the area of the rectangle and the square's area is same. So we can say the area of the square AS is also 16 square meter. Okay, but area of square is calculated as a square, where a is the side of the square. So a square is equal to 16, which gives a value as 4. So clearly the side of the square is nothing but 4 meter, given in option number D. Now, length of two diagonals of a rhombus are 10 centimeter and 8 centimeter. What is the area of the rhombus? So let us use the area of the rhombus formula. So area of the rhombus can be given by half of the diagonal 1 into diagonal 2, half of the diagonal 1 into diagonal 2, or we can call it as half of the product of diagonals. So clearly we have been given the diagonal length, so area of rhombus can be easily calculated as half of 10 into 8, that is nothing but 40 centimeter square. That is the area of the rhombus coming. It is available in option number A itself, becomes the right answer. Now he says that sides of a triangle are 3, 4, and 5 centimeter. What is the area of the triangle formed by joining the midpoint of the sides of the triangle? Okay, so he says the lengths are 3 centimeter, 4 centimeter, and 5 centimeter. But if you observe it carefully, then we can observe that 3 square plus 4 square is actually equal to 5 square. So the sum of the square of the two sides is actually coming equal to the square of the third side. But this only happens in the case of a right triangle. Okay, we can say this is 3, this is 4, and this is 5. This happens in a right triangle only. So clearly the triangle that has been indicated here is a right triangle. Okay, it is a right triangle. We can say that. Now area of the triangle will be how much? So area of this triangle will be nothing but half of base into height. That is nothing but half of base. Let's take anything base. Let's take the 3 as base, and let's take the 4 as height. So it will be ultimately this only. So it's becoming 6 centimeter square. That is the area of this whole triangle. But they're not asking for the area of this triangle. What are they asking is the area of the triangle formed by joining the midpoints of this triangle. So if you join the midpoint of this triangle and then you try to form the area. So if you join the midpoint of the triangle in a right triangle, the area created of that particular triangle is actually 1/4 of the total triangle area. So we can say that the area that they are asking in the question is actually 1/4 of the whole triangle area. Let's say the triangle was ABC. So it is equal to 1 by 4 of triangle ABC. And we are discussing the area of DEF here. Okay, so area of triangle DEF is actually equal to 1 by 4 of triangle ABC. So it can be 1 by 4 of 6, that is nothing but 3 by 2 centimeter square. So that is the right answer, which is available in option number A. It says length of a rectangle is halved while its breadth is tripled. What is the percentage of increase in the area? Okay, this is what is the question given. So for these type of question, we first assume some length and breadth, and then we find out the area. Then we change the length and breadth as per the questions, as per the given in the question, and then we try to find the new area, and then we compare the old area and the new area for any change. Okay, so let's say the length of this particular length of this particular rectangle is L, and the breadth of the particular rectangle is, let's say, B. So what is the area? Area is always equal to length into breadth, so area is LB. Now he says length is half, so length is taken as L by 2. Okay, and area is and breadth is triple, so breadth will be 3B. So the new area will be 3 by 2 of LB. So this is the new area. Okay, the older area is LB. Okay, so they're asking for what is the percentage of increase in the area. So first of all, we'll find out the increase in the area. Increase in the area is obviously the new area 3 by 2 LB minus the old area, that is LB. So the increase in the area is nothing but 1 by 2 of LB, that half the area is changed. So he's asking for the required percentage change. So half of area change is nothing but equal to half of change is always equal to the change of 50%. So we can clearly say the change percentage increase in the area is nothing but 50%, that is available in option number B. He says a circular playground is surrounded by a 21-meter road. The radius of the ground is 100. Find the area of the road. So let us draw the diagram first. There is a circular ground and it is surrounded by a 21-meter road. So this is the road's length, width rather, 21 meter. and the radius of the ground is 105. So let's take the center here, and this is the radius. The radius of the ground is 105 meter, and the road is 21 meter wide. Find the area of the road. He wants us to calculate area of the road. So area of the road or the area of the shaded portion. Okay, let's say this is the shaded portion where the road is. So clearly area of this shaded portion, okay, let it be a road, let it be any river or anything, area of this shaded portion is always calculated by area of the outer circle, area of the outer circle minus area of the inner circle, minus area of the inner circle. This is how it is calculated always. Okay, so an area of the circle is given by pi r square. So we can clearly write it has to be pi capital R square minus small r square, because let's say the larger radius is capital R and smaller radius is small r. So how much is the larger radius? Is going to be 105 plus 21. So it is going to be 105 plus 21, that is nothing but 126 meter. What is the small radius? Small radius is the radius of the inner circle, that is 105. So if we want to calculate the area of shaded portion, it has to be pi capital R square minus pi small r square. So if we take the pi common, it is left out as capital R square minus small r square. Let us use this formula. We have got capital R and small r both. Okay, so the area of the shaded portion is nothing but pi. Capital R is 126 square minus 105 square. So we need to solve this particular thing. To solve further, pi value is always 22 by 7. So it has to be 22 by 7 into 231 into 21. If we solve this further, this comes out to be 15,246 meters square. So this is the area of the shaded portion, or the area of the road given there, 15,246 meters square. This matches with option number B. So this is the right answer. Now, height of an equilateral triangle is 10 centimeter. Find its area. There is an equilateral triangle. Okay, so let's draw it. This is the equilateral triangle. Height of this is given as 10 centimeter. Okay, the height of it is given as 10 centimeter. He wants us to calculate the area. So we have so we can find out the side of an equilateral triangle using the area directly. Okay, height of an equilateral triangle is given and we can find out the side of it. So in an equilateral triangle, the side of the equilateral triangle can be directly calculated using the formula as 2 by root 3 into the height. Okay, in an equilateral triangle, side can be directly calculated as 2 by root 3 into height. So what is the side of this particular equilateral triangle is coming? Is 2 by root 3 into the height value is how much? Height value is given to be 10 centimeter. So it comes out to be 20 by root 3 centimeter. That is the side of the equilateral triangle. Now he wants us to calculate the area of the equilateral triangle. Area of the equilateral triangle, there's one more formula for that. Area for the equilateral triangle can be found out by there's a direct formula, that is root 3 by 4 into side square. That is the formula. So let us use this formula to find out the area. So it's going to be root 3 by 4 into side value is 20 by root 3's whole square. Okay, so if we solve this further, this is going to be root 3 by 4 into 400 by 3, and further solving it gives us 100 by root 3 centimeter square. So this is the area of that equilateral triangle, 100 by root 3 into centimeter square. That is option number A becomes the right answer. Now he says an equilateral triangle, a square and a circle have equal parameters. Parameters are the outer boundaries length. Okay, if T denotes the area of the triangle, S the area of the square, and C denotes the circle, then which of the following is right? Okay, so he says the parameter of all the things are equal. So let us assume that parameter. Let that particular parameter which is equal in all the three cases, let that parameter's length is x meter or x centimeter, anything. Then he says, let's compare for one by one for each shape. First of all, we have got an equilateral triangle. So equilateral, in an equilateral triangle, all the sides are equal, and if the sum of these side is becoming x, then the side of the equilateral triangle will be, each side of the equilateral triangle will be how much? Will be x by 3, because the sum of the side is x. So each side is equal. So each side length will be 1/3 of the perimeter, that is x by 3. Now we need to find out the area. So the area of the equilateral triangle, there is a direct formula, that is area is equal to root 3 by 4 into side square. That is the direct formula of equilateral triangle. If we use this, this is going to be root 3 by 4 into side value is given as x by 3's whole square, which comes out to be x square into 12 root 3. That is the area of the equilateral triangle coming out. Now let's come down to square. So square has got all the sides equal. So if the length of the perimeter of the square is x, then side of the square will be what? Simply x by 4, because the total sum of all the side is x and each side is equal. So each side is actually equal to 1/4 of the total perimeter, that is x by 4. Now we need to find out the area. Area of the square is simply given as a square, or the side square. So it has to be x square by 60. So that is the second area of the square. Now we are supposed to find out the case for our circle. A circle has got a circumference, okay, and that is the perimeter only. The circumference is actually related by 2 pi r, okay, where r is the radius, and this value is given as to us as assumed as x. So here we can find out the r value as x by 2 pi. We can find out the radius of the circle as 2 pi. Now area of the circle is nothing but pi r square. So if you put the r value here, area can come out to be pi into x by 2 pi whole square. If we solve this further, this comes out to be area of the square. If we solve, this is coming out to be in place of r we have placed x, so it comes out to be ultimately 7x by 44. So these are the three areas that we have got: 7x by 44 for circle, x square by 16 for square, and x square 12 root 3 for equilateral. By comparing these three things, we can jump to a conclusion that area of the circle is largest, area of the square is second largest, and area of triangle equilateral triangle is smallest. So the right answer for this particular case should be option number B, which matches with the above criteria. Now the question says the number of revolution of a wheel of a diameter 40 centimeter makes in traveling a distance of 176 meter. So every time a wheel takes one revolution, every time a one wheel takes one revolution, it actually covers the distance that is equal to the circumference of the wheel. Circumference of the wheel. Okay, whenever the wheel takes one revolution, it actually covers circumference of the wheel. Now what he has done, the number of revolution of a wheel of a diameter 40 centimeter makes in traveling a distance of 176 meters. So that's what we are supposed to calculate. In 176 meter, how many revolution he is supposed to take. So clearly we need to find out what is the distance covered in one revolution, that is circumference. The circumference is given as 2 pi r. Here the diameter, that is 2r, diameter is d is equal to 2r, is given as 40 centimeter. Okay, so the circumference, or the one revolution distance covered, one revolution distance covered is equal to 2 pi r, that is 2 into 2r into 22 by 7. 2r value is already with us, that is 40, so it's going to be 40 into 22 by 7. This is the distance covered in one revolution, the 40 into 22 by 7 centimeter. Then the total distance to be covered is 176 meters. So how many revolution will be required? So number of revolution is always calculated as total distance to be covered, divided by distance covered in one revolution, one revolution distance. Okay, so the total distance is 176 meters. So clearly we'll have to convert this into centimeter, because 1 meter has got 100 centimeters. So we'll multiply it by 100 divided by the distance covered in one revolution is 40 into 22 by 7. So clearly we need to solve this particular mathematical expression to give away the right answer. If we solve this further, this comes out to be 176 into 100 into 7 divided by 2 into 22 into 20. That is actually, by after solving, we can find out this value is actually coming equal to 140. So that is the number of revolution that the wheel has to take to cover a distance of 176 meter. Okay, so that is the answer, option number A. Now let's have the next one. A circle and a square have same area. Therefore, the ratio of the side of the square and the radius of the circle is. Okay, he says the circle and a square have same area. Okay, so in this case what we can do is, if he's saying the same area of the square and circle is there, so let us assume that same area is x. Let the area that is same for circle and square. Circle and square, let's say that particular area is nothing but x. Now we can, in terms of x, we can find out the side for the square and the radius for the circle. He's asking for the ratio of the side of the square and the radius of the circle. So for the square case, the square's area is given as side square. Okay, and the side square value is coming out to be x. So side value is simply, so the side value is simply under root of x. So the side of the square is nothing but under root of x. Now, for the case of circle, okay, the circle's area is given as pi r square, and this area is already given to be x. So we can find out r square is equal to x by pi. So r value is root of x by pi. So this is the radius of the circle. This is the side of the square. He's wanting us to calculate the ratio between square sides of the square and the radius. So he's asking for the ratio between side and the radius. Okay, we have calculated both the things in terms of the x. So it's going to be root x is to root x by pi. Okay, if we solve this further, this ultimately comes out to be root pi is to 1. This ultimately comes out to be root pi is to 1. So that is going to be the answer. Let us see where it is available. It is available in option number C. Now, the areas of two concentric circles forming a ring are 154 square centimeter and 616 square centimeter respectively. Width of the ring is. So let us make the two concentric circle. Concentric circle are the circle which are created from the same center with different radiuses. So these are the two concentric circle formed. He's saying one, the inner circle may be having the lesser area. So this circle is having the area of 154 square centimeter, and the larger one is having the area of 616 centimeter square. He wants us to calculate the width of the ring. So let us dedicate the radius values. Let's say the small circle has a radius of small r, and the larger circle has a radius of capital R, like that. So whatever will be the width value will be nothing but capital R minus small r. That will be the width value that we are supposed to calculate. So let us equate the area. Equate the area of the larger circle will be pi capital R square, and that is given out to be 616 square centimeter. Similarly, area of the small circle will be pi small r square, that is given out to be 154 square centimeter. Now we can calculate the r value from both the cases. So here r square is equal to 616 divided by pi, that is 22 by 7. If we calculate this further, the r value comes out to be root of 196, that is r value comes out to be 14 centimeter. Okay. On the other hand, if you want to calculate small r square is going to be 154 divided by 22 by 7. So R value is clearly under root of 49. If you calculate this further, the R value is coming out to be under root of 49. That is R value is nothing but 7 centimeter and 14 centimeter for this case. Now he wants us to calculate the width of the ring. The width of the ring is nothing but, as indicated in the figure also, capital R minus small r. So it's going to be 14 minus 7. That is nothing but 7 centimeter is the final answer. That is available in option number B. Now, the length of one pair of opposite sides of a square is increased by 5 centimeter on each side. The ratio of length and breadth of the newly formed rectangle becomes 3 is to 2. Find the area of the original square. So this question can be understood by drawing. First of all, they had a square. The square has got each side as equal. Then they did what? They transformed this to by doing one pair of opposite side of a square is increased by 5 centimeter on each side. That is, let's say this particular length has been increased by 5, so we can write it as a plus 5. And he says each side, so the other side is also increased by 5, so this is also a plus 5. Breadths are as it is same. So this is the new transformed figure, a plus 5, a plus 5, the length have been increased. He's saying if you transform like that, then the ratio of the length and breadth of the newly formed rectangle is 3 is to 2. So length is a plus 5 divided by breadth is still a, and this ratio is coming up, he's telling us as 3 is to 2. This is the new ratio, so we can calculate this by doing the cross multiplication. So 2a plus 10 is equal to 3a, which gives the a value as nothing but 10. He's asking for the find the area of the original square. Original square had got the side as a, so the area is nothing but side square, so that is 10 square, that is nothing but 100 centimeter square. That is the right answer, available in option number B. Now the question says, what will be the area of the circle having circumference equal to 56 centimeter? So circumference of a circle is given by circumference of a circle is given by 2 pi r, and this value is given equal to 56, where pi value is 22 by 7. So clearly r can be written as 56 divided by 2 pi. Okay, so we need to find out the this r value, which is nothing but 56 divided by 2 into 22 divided by 7, which is making r value equal to 8.91 exactly. Now he wants us to calculate the area of the circle. So area of the circle can be calculated using the pi r square. So let us find out this value. So it's going to be 22 by 7. And in place of r, we could have just used this directly instead of finding out the decimal value. So pi is 22 by 7 and r is 56 by 2 into 22, and the 7 goes up into 7 whole square. This is what we are supposed to calculate. If this is calculated further, this can be coming close to somewhere close to 250. This is approximately coming somewhere close to 250 or 249. So let us see where it is available. It is available in option number B. Most close to 250 is 249.45 centimeter square. That's why this is becoming the right answer. Now, a rectangular field is to be fenced on three sides, leaving a side of 20 meter uncovered. If the area of the field is 680 meter square, how many meter fencing will be required? So let us make the rectangular field. So this is the breadth, and this is the length, and this is the breadth, and this is the length. He's saying the field is to be fenced on three sides, leaving a 20-meter side uncovered. So let's say this is that side that is to be left uncovered of 20 meter. So the side opposite to it will also be having same length, and the other two sides that the length that the breadth are not given. So let us assume the breadth to be b and b, like that. We are supposed to fence around these three sides. We are supposed to fence around these three sides and leave this particular side as open. Leave this particular side as open. This is what we have to do. He says three sides leaving a side of 20 meter uncovered. So 20-meter side has been left uncovered. Now then it has been fenced. Okay. He says the area of the field is 680 meters square. So we'll use this. So we have taken L as 20 meter. So the breadth value we have taken as just B. So the area will be nothing but length into breadth, that is 20B. 20b is equal to area given as 680 meter square. So using this, we can calculate the b value, that is 680 divided by 20, which is nothing but 34 meters. So the breadth value has come out to be 34 meter. Now he wants us to calculate how many meters fencing will be required. So the fencing will be required as b plus 20 plus b again. These are the three sides cover, b plus 20 plus b. If you add them together, it is going to be 2b plus 20, that is nothing but 2 into 34 plus 20, that is nothing but 88 meters. So that is the fencing length required, which is available in option number D, becomes the right answer. Now he says the area of the largest triangle that can be inscribed in a semicircle of radius r is. Okay, so let's create a semicircle. Semicircle is like this, where this particular straight line is a diameter. Okay, let's say the diameter length is d, or we can this let's play the center here, or we can break down that into radius form r and r, and one more r goes like this. So this is what is the semicircle. Okay, he's saying the largest area of triangle, largest triangle area that can be placed here is. So clearly we are supposed to find out the radius, find out the area of that particular triangle also. So clearly we can do what thing, that we can take one side as d itself. Another side we can create the another side if the height is the maximum. Okay, and height of this triangle will be maximum when r is treated as the height itself. Okay, so this will be that biggest triangle, like this will be that biggest triangle in which the height is the maximum length possible, that is r. So height of this triangle is going to be r, and the base of this triangle is going to be twice of r, that is the diameter. So area of this triangle, new triangle, will be, area is always calculated as half of base into height. It is equal to half of base value is 2r into height value is r, which gives us the value as r square of the area. So that is the right answer. R square will be the maximum area triangle that can be inscribed in a semicircle. Now, the question is, a room having length 15 meter by 12 meter, what will the total cost of the floor is made at rupees 125 per meter square? So clearly, for 1 meter square area, the floor cost is 125 rupees. He wants us to calculate the total total price of covering the particular field, covering the particular room. So for that case, clearly we are supposed to find out the area of the room first, floor first. So length is given as 15 meter, our breadth is given as 12 meters. So the area of the rectangle is always L into B. If you multiply it together, this is going to be 15 into 12, that is nothing but 180 meters square, that is the area. For 1 meter square, the cost taken is 125, as stated, 125 per meter square. Cost taken is rupees 125. We have got an area of 180 meters square, so the cost of 180 meters square will be, unitary method says it will be 125 into 180 rupees. If we solve this further, 125 into 180 is coming as 22,500 rupees. So that is the ultimate price of costing the of total cost of the floor to be made, 22,500. It is available in option number C becomes the right answer. Rather, it be available in option number D becomes the right answer. Now, if the circumference of a circle is equal to the perimeter of a square, circumference of a circle is equal to perimeter of a square, then the areas are in the ratio. The circumference, so circumference of a circle is equal to area, is equal to perimeter of a square. Circumference belongs to circle only, and perimeter can be of any quadrilateral. Perimeter of the square. So what is the area, the formula for circumference? It's going to be 2 pi r is equal to perimeter square. Square of perimeter is nothing but 4 into the side. So let's say the side value is a. He want us to calculate the areas. Then their areas are in the ratio. So we have to give the ratio of the areas. So this is the. So let us find out the ratio of the radius and the side first. So if you want to calculate r by a, this is going to be 4 by 2 pi. That is nothing but this is going to be 4 by 2 pi. So that is nothing but 2 by pi rather. So this is what is r by a, or we can say the radius is nothing but twice of a by pi. We can say like that. The radius nothing but twice of a by pi, where a is the side length of the square. Now he wants us to calculate the ratio of the areas. So let's say the area of the circle we'll take first, because that is first in the order, circle, and then the square is in the order. So area of circle is to area of square. This will be the order that we'll take. Area of circle is given by pi r square, so it's going to be pi r square is to side square, that is a square. We have transformed r in the form of a, so we can replace this r's value. So it is going to be pi into 2a by pi whole square is to a square. Let us solve this further. So this is coming out to be 4. If we put the value of pi as well, so this is coming out to be 4 is to 22 by 7. If we further simplify this, this particular ratio becomes 14 is to 11. So that is going to be the right answer. 14 is to 11 is the ratio of the square, circle to the area of square, which is available in option number A. Now, a circular park has a path of uniform width around it. So there is a circular path to be drawn. The difference between outer and inner circumference of the circular path is 132 meters. So we can draw it always. So this is like a circular path. There is a circular path like this, which is shaded. He says there's a width of it, and the difference between outer and inner circumference of the circular path is 132 meters. So difference between two circular path is 132 meter. Circumference is nothing but the 2 pi r. So let's say the larger circle has got a radius of capital R, the smaller circle has got a radius of small r. So clearly the width value, the width is nothing but circumference of the outer circle minus circumference of the inner circle. This is what is the width. Okay, so what is the circumference of the outer circle? It's going to be 2 pi capital R minus 2 pi small r. This will be the width value. Okay, and this width is already given to us as 132. So we can take the 2 pi as common and calculate the r minus r small r value. That is nothing but 132. Okay, so if we solve this further, for small capital R minus small r, it is going to be 132 into 7 divided by 2 into 22. If we solve this, this comes out to be 21 meter. So r minus r value is coming out to be 21 meter. That's what they had asked. What is the width of the circular path? Rather, find its width. So width of the circular path has come out to be 21 meter, and that is the final answer. It is available in option number A. Now, the next one he says the area of a triangle is 1176 centimeter square, and base is to corresponding altitude. Base is to altitude ratio is 3:4. This is what is given. then what is the altitude of the triangle? So let's create the triangle. This is the triangle. He's saying the area is already given as 1176 centimeter square. This is the base and corresponding altitude. So this is the corresponding altitude. Altitude is nothing but the height of the triangle. So this is the corresponding altitude. He says the ratio is 3 is to 4. So let us assume the base is to altitude is given as 3 is to 4. So let us assume the base value is nothing but 3x. The altitude value is nothing but 4x, and he's given the area. So area of a triangle is always given by half of base into height. If we solve that, this is coming to be half of 3x into 4x, and this area is given as 1176 meters square already. So we are clearly supposed to solve this particular expression. So if we solve this, this gives us x square is equal to 196, which gives us x value as simply 14. So that is what is the answer. The side of the rather the x factor is 14 centimeter. We are supposed to find out the altitude of the triangle. We had assumed the altitude to be 4x. So using x as 14, the 4x can be calculated as 14 into 4. That is 56 centimeter. Let's see where it is available. It is available in option number A. So it becomes the right answer there. In the next question, he says the three sides of a triangle are 3 centimeter, 4 centimeter, and 5 centimeter. So if you have a closer look at these three sides, the you can understand that this is 3 square plus 4 square is actually 5 square, which is the law of a Pythagoras theorem. So clearly this indicates that this particular triangle is a right triangle like that, and this could be 3, this could be 4, and this could be 5. It is like this. So this indicates that it is a right angle triangle. Now the area of the right angle triangle is nothing but area is equal to half of base into height. We can make anything as base and anything as height. So it is going to be half of 3 into 4. That is nothing but 6 centimeter square. So this is what is the area of the triangle comes out to be, and it is available in option number B. It becomes the right answer. Now, a piece of wire of 78 centimeter long is bent in the form of an isosceles triangle. Isosceles triangle is a triangle in which the two sides are equal. If the ratio of one of the equal sides to the base is 5 is to 3. So let us create this diagram. Okay, let's say these two sides are completely equal, and he's saying that ratio of one of the equal sides to the base is 5 is to 3. So let's say the base value, one of the equal side to the base is 5 is to 3. So let's say the base is 3x, the other sides are 5x and 5x. Now the ratio of base to the ratio of the equal side, that is 5x, to the base is 5 is to 3 maintained. So this is how we have taken. It is an isosceles triangle. He's saying piece of the wire 78 centimeter long is bent. So if the piece of wire has been bent in the shape of isosceles triangle, then that means perimeter of this triangle, that means the perimeter of this triangle will be actually equal to 78 centimeter. That is the length of the whole boundary. Okay. So let us create the perimeter. Perimeter of a triangle is nothing but sum of the sides. So the sides are 5x plus another 5x plus 3x is equal to 78 centimeter. If we solve this further, this becomes 13x is equal to 78, which gives us x value as 6. Now we are supposed to calculate the length of the base. So base we had assumed to be 3x. So the length of the base is nothing but 3 into 6, that is 18 centimeters. So this is the right answer. B value is 18. Let us see where it is available. It is available in option number C becomes the right answer for us. Now, if one side of and one diagonal of a rhombus are 5 centimeter and 8 centimeter respectively. So let us create a rhombus out of it. Let us create a rhombus. Okay, this is a rhombus looking shape. Is saying one side and one diagonal. So let's say this is 5. The property of rhombus is that all the sides are equal, and diagonals are perpendicular bisectors of each other. So all the sides are 5, 5 and 5. Now let us create the diagonals. This is how the diagonals go. Okay, then he says that one side of the and one diagonal of a rhombus are 5 and centimeter and 8 centimeter. Let's say that this particular diagonal is of length 8 centimeter. This particular diagonal is of length 8 centimeter. Diagonals are perpendicular bisectors of each other. So that means this is 4 and this is 4. Okay, and we are having a right angle created on the top of it. If you can see this figure, this is nothing but a right angle triangle. It's looking like this. Okay, so this is 5 centimeter, this is 4 centimeter, and this is a 90 degree. If you can see it like this. Now what he's asking for then the area is. So we are supposed to calculate the area. So clearly we want to calculate this particular length. Let us name it A, B, and C. So we want to calculate AB using Pythagoras theorem. Because it is a right angle triangle, so we can always create the Pythagoras theorem. So by using the Pythagoras theorem, we can find out the length of AB as AB square plus 4 square is equal to 5 square. This we have done using the Pythagoras theorem, which gives AB square value as 25 minus 16, that is 9, which gives the AB value as 3. So now this particular value of AB is 3. So in the figure, if you can see, since the diagonals bisect each other and the top length has come out to be 3, then the bottom length will also be 3 because they are equally bisected. So we can say the length of the other diagonal T2 will be 3 plus 3, that is 6 centimeter. And length of the first diagonal he has already given to us. Length of the first diagonal is nothing but 5 centimeter. He has length of the diagonal of the first diagonal is already given to us as 8 centimeter. Okay, so we have got both the diagonals with us. Now we are supposed to calculate the area. Area of the rhombus is given always by half of the product of the diagonals. Half of product of the diagonals. So let us do it. Half of the first diagonal is 8 and the another diagonal is 6. So if we calculate this, this comes out to be 24 centimeter square. So that is the area of the rhombus, 24 centimeter square. Let us see where it is available. Available in option number C. So becomes the right answer. Now, a rectangular carpet has an area of 120 meter square and a perimeter of 46 meter. Okay, so the rectangle has got an area of length into breadth. So let's say the length value is L, and let's say the breadth value is B. He says the area is 120 meter square, so LB is 120 meter square. Okay, and a perimeter of 46 meter. Perimeter is always given as 2 into L plus B. 2 into L plus B value is given as 46 meter. Now, using these two equation, we need to solve the particular value of length of its diagonal. Okay, so clearly we'll have to use some tricks here. L plus B, L plus B can be calculated as 46 by 2, that is nothing but 23 meter. Okay, if L plus B value is 23, then using this L plus B, there's a formula that can calculate L minus B. What is that formula? L minus B can be calculated by under root of L plus B's whole square minus 4LB. So if we use this particular formula, we can easily find out L minus B, and then we can make the simultaneous equations. So from here, L minus B can be calculated by under root of L plus B whole square. L plus B is 23, so it's going to be 23 square minus 4 times LB is 120. So it's 4 times 120. It's like this. So here where L minus B comes out to be, if we solve this, this comes out to be 23 square minus 4 times 120, which is coming as under root of 529 minus 480. If we solve this, this comes out to be under root of 49, that is nothing but 7 unit. So L minus B is coming as 7. L minus B is 7. So we can take this as equation number 2, and L plus B is 23. We can take this as equation number 1. Solving these two equations, by adding these two equations, we can get 2L is equal to 30. So L value comes out to be 15 units. And by the same thing, we can calculate the L value has already come out to be 15, and by same thing we can find out the B value as, so L minus B was 7, so B value has to be 8. Okay, so L and B have come 15 and 8. Then he wants us to calculate what? He wants us to calculate the length of the diagonal. So in a rectangle, things like this. So this is how the diagonal goes. This is the length, this is the breadth. So again, this is a rectangle. Again, this is a right angle triangle. So diagonal's length is nothing but under root of L square minus B square using the Pythagoras theorem. So diagonal's length is nothing but under root of L square minus B square, that is 15 square minus 8 square, that is nothing but under root of 289, which is equal to 17 centimeters. So that is the length of the diagonal of this rectangle carpet is 17 rather meter. Let us see, it is available in option number C, becomes the right answer. Now the area of a rhombus is 96 centimeters square. If one of the diagonals is 12 centimeter, then the other diagonal and the side of the rhombus are respectively. Okay, so we know the area of the area of the rhombus formula. Area of the rhombus is nothing but half of product of diagonals, diagonal 1 into diagonal 2. Area of the rhombus is already given to as 96. So half of one of the diagonal is given as 12. So half of 12 into the d2 we have to calculate. So clearly the d2 can be calculated as twice of 96 divided by 12, that is nothing but 16 centimeters. So we have got both the diagonals with us. First diagonal is of length 12 centimeter as given in the question itself. Another is of 16 centimeter. So the diagonal length has come. He also asked for the side of the rhombus. Okay, side of the rhombus is also asked. So if we create a rhombus like this, okay, so this is the diagonal. Let's say this diagonal is 16 one and the other diagonal is 12, and that all the sides of a rhombus are always equal. So we can say that the this and this particular diagonal creates, but the particular diagonals are perpendicular bisectors of each other. So this way the side of the rhombus can be directly calculated. Okay, side of the rhombus can be directly calculated by under root of the and perpendicular bisect, the diagonals are perpendicular bisectors. First diagonal is of 16 centimeters, so the half of 16 is 8 here, and another diagonal is of 12 meters, so the half of 8 is 6 here. So we have got a right angle triangle like this, where this length is 8, this length is 6, and we are supposed to calculate the side. Okay, and there where it is a right angle. Okay, so they clearly we can use the Pythagoras theorem in this to give away our the side value. So the side square is always going to be 6 square plus 8 square. So in this way, the side can be calculated as under root of 6 square plus 8 square, that is nothing but under root of 100, which comes out to be 10 centimeters. So this is what is the side of the diagonal, side of the rhombus. So the value set should be diagonal first, then rhombus. So it should be 16 and 10 centimeter. Let us see where it is available. It is available in option number C. So becomes the right answer here. Now, the cost of fencing a square garden is 400 at the rate of rupees 1 per meter. Okay, so for 1 meter, the cost is 1 rupees. So for so we can say 1 rupee is the cost of 1 meter. So 400 rupees will be the cost of how many meters? Clearly 400 meters. Okay, so by this way, we can find out the length of the fencing. The length of the fencing is how much? Length of the fencing is clearly 400 meters. Okay, then he asked the area of the garden. So length of the fencing of a square. So a square has got a fencing or the circum or the perimeter as the perimeter of the square. Perimeter of the square is nothing but 4 times the side, so which is given as 400. So clearly A can be written as 400 by 4, that is 100 meter. So that is the side of the square is. He's wanting us to calculate the square area of the square. So area of the square is given as side square always. Okay, side value is 100, so it's going to be 100 square, that is nothing but 10,000 meters square. That is the area of this particular square is. And let's see where it is available. It is available in option number D, so it becomes the right answer there itself. Then the length of a rectangular plot is 20 meter more than its breadth. If the cost of fencing the plot at the rate of rupees 26.50 per meter is rupees 5300, then find the length of the plot. So we'll use this rate first. He's saying cost of fencing the plot at the rate of rupees 26.50 per meter. So the 1 meter has got a cost of rupees 26.50. Okay, then 1 meter has a cost of 26.50, then 5300, rather we can reverse this. 26.50 rupees is the cost of 1 meter of the fencing. Then 1 rupees will be the cost of 1 rupees will be the cost of how much? 1 by 26.50 meter of the fencing. Then 5300 rupees will be the cost of how much fencing? That is 1 by 26.50 into 5300 rupees fencing. So if we cut this like that, this comes out to be clearly 200. So this gives us the value of the circumference. The circumference value comes out to be 200 meter. Now, what he has given, length and of a rectangular plot is 20 more than its breadth. So let's say the breadth value is x. So the length value will be 20 meter more. So it will be x plus 20. So these are the length and breadth that we have assumed. Now we can use the formula of the perimeter and make it equal to 200 meter. The formula for perimeter is 2 into L plus B, and this is given as 200. So we can put the value of length and breadth. So it's going to be 2 into length value is x plus 20 plus breadth value is x is equal to 200. If we solve this further, this is going to be 2x plus 20 is equal to 100. So we can solve this further. This gives us x value as 100 minus 20, that is 80 by 2. X value comes out to be 40. What he wanted us to calculate, find the length of the plot. Length we had assumed to be x plus 20, so it has to be 40 plus 20, that is 60 meters. So that is the actual length of the particular rectangular plot is 60 meter. It is available in option number B, so becomes the right answer there. Now, the length of a rectangular hall is 5 meter more than its breadth. The area of the hall is 750 meters square. What is the length of the hall? Okay, so let us assume, in this case, we assume one of either of the length or the breadth. Okay, the length is 5 meter more than its breadth, so it's better to assume the breadth. Okay, the breadth value, let's say, is x meter. So the length value will be how much? So the length value he has said is 5 meter more. So it has to be x plus 5 meters. So these are the length and breadth. He's saying the area of the hall is 750 meters square. Area of a rectangle is always L into B as given as 750. Let us put the values of length and breadth. It's going to be x plus 5 multiplied by x is equal to 750. Clearly, we can make the equation out of it. So it's coming out to be x square plus 5x minus 750 is equal to 0. Now, this particular equation can be solved by multiple ways. It can be solved by Sridharachar as well. It can be solved by the prime factorization method as well. So, while solving this, we can get to the factors as x minus 25 and x plus 30 equal to 0. So, two values are coming as x equal to minus 30 and another value is x equal to 25. Negative value cannot be taken because we are dealing in the dimensions. So x value is taken as 25. So the x value is 25. They have asked for the length. So the length of the hall is going to be x plus 5, where x value is 25. So it's going to be 25 plus 5, that is 30 meter is the length of the hall. Let's see where is this available. It is available in option number B. So it becomes the right answer. Now he says sides of a triangle are in the ratio 1 by 2 is to 1 by 3 is to 1 by 4. If the parameter is 52 centimeter, then find the length of the smallest side. So the ratios of the sides are 1 by 2 is to 1 by 3 is to 1 by 4. Clearly we'll have to convert this ratio into the normal whole numbers ratio. For doing that, we can take the LCM of the denominators. LCM of 2, 3, 4 is clearly going to be 12. Now we can operate these numbers. 2 divides 12 by 6. So it is 6. 3 divides 12 by 4. So it is 4. 4 divides 12 by 3. So ultimately this 1 by 2 is to 1 by 3 is to 1 by 4 is actually the ratio 6 is to 4 is to 3. Okay. Then he said the parameter is 52. So for parameter, we need to have the length of the sides. So let us assume the sides are of 6x, 4x and 3x unit. Now the parameter is sum of all the sides. So let us do the sum of all the sides. 6x plus 4x plus 3x is equal to the length of the parameter, that is 52. If we solve this further, this is coming out to be 13x is equal to 52, which gives x value as 4. By using the x value of 4, we are supposed to find the length of the smallest side. Obviously, the smallest side will be the 3x one. So smallest side value is nothing but 3 into 4, that is nothing but 12 units. So that is the right answer. 12 centimeter is the length of the smallest side. It is available in option number B. So becomes the right answer here. Now it says one of the diagonals of a rhombus is double the other diagonal. Okay. So let's say the first diagonal is D1. The diagonal 1 is double the second diagonal. So diagonal 1 is twice of D2. Okay. Its area is 25 centimeters square. Find the sum of diagonals. So we are supposed to find the sum of diagonals. Now for the rhombus, the area formula is area of a rhombus is given by half of product of diagonals. Half of product of diagonals. Let us put down the values. So it can be written as half of D1 can be replaced by twice of D2 into D2 is equal to the area. Area is already given to us as 25. So we can put it 25 here. If we solve this further, this comes out to be D2 square is equal to 50 by 2, or dt square is equal to 50 by 2, that is 25, which gives us the d2 value as root 25, which is 5. So diagonal number 2 has come as 5 and diagonal number 1 has to be twice of d2. So it is twice of 5, that is 10 centimeter. Okay, so both the diagonals length have come. He's asking for find the sum of diagonals. So sum of diagonal is nothing but d1 plus d2, that is 5 plus 10, that is 15 centimeter is the sum of the diagonal. Let's see where it is available. It is available in option number D, so it becomes the right answer there. Now, he says each side of a given square is 5 centimeter, and assuming the two opposite side of the square as diameters, two semicircles are drawn in the inside of the square. Okay, so we need to first create the diagram as he has said. If these semicircles are cut down from the square, so further he says more things. Let us see the figure first. Each side of a given square is 5 centimeters. So let's create the square first. So this is that particular square that we have, 5 centimeter. Each length is 5 centimeter. We can name these points also. Let us start from here. It is A, B, C, and D. Then he says assuming the two opposite side of the square as diameter. So let us take down the DC as one of the diameter and AB as another diameter. Two semicircles are drawn in the inside of the square. So let us draw from in the inside of the square the two semicircle like this. Obviously they will be touching because the diameter has been same. So this is how the figure looks like. Both are semicircles. Then he says if these semicircles are cut out from the square, so these semicircles are completely removed from the complete diagram, he says then the area of the remaining portion of the given square will be what? So clearly we can understand the area of the remaining portion. Area of the remaining portion will be area of the square, the complete square, minus twice of area of the semicircle, twice of area of the semicircle, because both the semicircles will be having similar area, so we can write it like twice the area of the semicircle. So let us find out the area of the square first. So area of the square is always given by side square, length is 5, so it's going to be 5 square minus twice of area of the semicircle. Area of a circle is given as pi r square, so the area of semicircle is nothing but 1 by 2 pi r square. Okay, so it is going to be 2 into 1 by 2 of pi r square. Pi value is as it is pi, and radius of this semicircle. Okay, so clearly the diameter of this semicircle is 5, so the radius of this semicircle will be what? Simply 5 by 2, and both the circles are equal, so both the radius are just 5 by 2. So pi into 5 by pi by 2 square, this is what it is, the expression. If we solve this further, this is coming out to be 25 minus 2 and 1 by 2 gets cancelled, so it's coming out to be 22 by 7 into 25 by 4. So we clearly need to solve this particular expression. If we solve this, this comes out to be 25, and rather the options are given in terms of pi only, so we don't need to create this 22 by 7 into pi. We'll let it be like pi only, so it's coming out to be 25 minus 6.25 pi. So this is what is the area coming, 25 minus 6.25 centimeter square. Let's see where it is available. It is available in option number B itself, 25 minus 6.25 pi square centimeter. Now, a 1 meter long rope has been given the shape of a circle. So, whenever a 1 meter long rope was there and it is transformed in the form of a circle, then obviously this 1 meter will be nothing but the circumference of that circle. So, the circumference of the circle becomes now 1 meter. Okay. He's asking for the area of the circle. So clearly circumference of a circle is given by the formula called as 2 pi r. So clearly here where the 2 pi r is equal to 1 meter. So we can calculate the r value as 1 divided by 2 pi. Now he's wanting us to calculate the area of the circle. Area of a circle is always given by pi r square. So let us put the value of r in this particular area formula. So it's going to be pi into r value is 1 upon 2 pi whole square. So if we solve this further, this comes out to be area of the circle can be calculated, and obviously we'll have to use the value of pi as well. So if we simplify this, this coming out to be pi by 4 pi square, and this pi gets cancelled one time. So ultimately the area is coming out to be 1 by 4 pi. So clearly we need to solve this. 1 by 4 pi, if we solve, so it's coming out to be somewhere 8750 multiplied by 11 into 100 meter square. Okay, which is coming out to be exactly equal to 795.45 centimeter square, because the things are needed to be converted in a centimeter. That's why we are supposed to divide the particular area that is coming actually in meters by 100 square. So if we divide this, multiplying it by 100 square, so when we do this, we're going to get to the value as 795.45 centimeter square, which is available in option number B. Okay. Now, the area of a triangular field, the lengths of whose sides are 50, 78, and 112. So we have a triangle where the lengths are given as 50, 78, and 112. So clearly, when these type of situation is given, we can make use of the Heron's formula. Okay, what is a Heron's formula? Heron's formula is nothing but area of a triangle is given by under root of area of a triangle is given by under root of s into s minus a, s minus b, and s minus c, where this s is can be calculated as a plus b plus c by 2, where this a, b, c are nothing but the sides. So let us find out the s for our case. S is going to be side sum of all the side, that is 50 plus 12, 50 plus 112 plus 78 divided by 2, which comes out to be 240 divided by 2, which is nothing but 120. So S value is 120. So the area can be calculated by the formula given up. So it's going to be 120 under bracket 120 minus first side, that is 50, under bracket 120 minus second side, that is 112, under bracket 120 minus third side, that is 78. So clearly we are supposed to solve this for the purpose of area. So area is becoming like under root of 120 into 70 into 8 into 42. So we are supposed to find out the area of this. So clearly we'll have to break, for finding out the under 8, we'll have to break them into the factors. So if we broke down into factors, this will become like 2 into 2 into 2 into 3 into 5 into 2 into 5 into 7 into 2 into 3. So these are the factors. Okay. So if you want to take the under root, then clearly we'll have to take the pairs up. If we take the pairs, then area can be calculated as 2 to the power 4 into 3 into 5 into 7, which comes out to be area as 1680 meter square. So that is the right area. Let us see what is it is available. It is available in option number C. So it becomes the right answer there. Okay, so the question says a rectangular garden is 100-meter long, 80-meter wide. So we can make this. The garden looks like this: 100-meter long and 80-meter wide. This is how a rectangle looks like, 80-meter wide. And it says it is surrounded on its outside by a uniformly broad path. Let's make a uniformly broad path outside the rectangular garden. If the area of the path is 1900 meter square, so the area of this path is given as 1900 meter square. This is that shaded one whose area is 1900 meters square. Okay, then what is its width? Okay, so what we can do is to find out the width of particular uh, the particular outside path. Let's say the width, we can assume always the width can be assumed as x. Let's say this width is x. So to finding out that width, what we can do is we can calculate the rectangular gardens area, that is very inside, and the shaded area is already given to us. So the the shaded area can be always calculated by the area of the total rectangular portion, including the path also, minus the actual rectangular garden area. That gives us the shaded area or the area of the path. So we can create an equation in terms of this. Area of the path is already given to us, and we can find out the area of the rectangular garden also. So in terms of this, we can we can use x as width of the particular path, so x can be calculated. So that's what we're gonna do. So what we'll do is, let us assume the width is x. Let's say the width of the path is equal to x meter. Now what we can see area of the garden plus area of the path. Area of the garden plus area of the path is actually equal to total area including the path. Total area including the path. So this is how we can relate things. So let us do it. So the area of the garden. So area of the garden will be nothing but length into breadth. Length is 100, breadth is 80. So this is the area of the garden plus area of the path. That area of the path is already given to us. The area of the path is nothing but 1900 is equal to total area including the path. So for total area, we need to know the total length. So clearly 100 is the inside length and we have considered the width to be x. So x will be on right hand side also, and this x will be counted on the left hand side also. So actually this total length becomes 100 plus x, which is nothing but 100 plus 2x. Similarly for the width, the inside width is 80 meter, and there is a path of x over there and on the bottom side also. So the total width becomes 80 plus x. So that is the total breadth of the total area. So length and breadth gives a product of the area. So it's going to be 100 plus 2x, the length of the total portion, multiplied by 80 plus 2x, multiplied by 80 plus 2x. So this is the total area. So we are supposed to solve this particular mathematical expression for finding out the x value. If you try to do this, this becomes 4x square plus 360x minus 1900 equal to 0. This sums up to this. We can solve this. We can cut every number by 4. So it becomes x square plus 90x minus 475 equal to 0. For solving out this, we can break this into factor, and while we break this, we get two factors of it. One is x minus 5, another one is x plus 95. These are the two factors it is broken into, which gives us the two value of x. One is 5 and one is minus 95. Obviously, minus 95 cannot be taken because we are dealing in the dimensions, and dimension cannot be negative. So x value has come out to be 5 meter. That is actually the width of the path is, which was asked in the question. Answer becomes 5 meter. Now, he says diagonal of a rectangle is root 41 centimeter and its area is 20 centimeter square. Okay, diagonal of a rectangle. So let's make the rectangle like that, and its diagonal he has said is root 41. That is the value of the value of the diagonal, and its area is 20 centimeter. The area of the rectangular portion is given out to be 20 centimeter square. So let's say this is the length, and let's say this is the breadth. Okay, so what has been given to us? See, this in a rectangle, every angle is 90 degree. So if we look at this portion, this is nothing but a triangle where there's a right angle over there. So obviously, the if we name it like that, A, B, C, D, so obviously we can say that BD square is equal to L square plus B square. This is what we can say. We can apply a Pythagoras theorem in this particular triangle BCD. So BD square value can be root 41, that is the diagonal itself, square is equal to length square, which we don't know, plus breadth square, which we don't know. So this is how it can be related in terms of a right angle triangle. Now, let's see the other part of it. He says the area of the total rectangle is 20 centimeter square. Area is nothing but L into B. So L into B has said as 20 centimeter square. So we have got two things with that. One is L square plus B square is equal to 41. Another one is LB is equal to 20. So we have got two things here. What we are supposed to know? We are supposed to know the perimeter of the rectangle. Perimeter of the rectangle is always calculated as twice of L plus B. This is the formula for perimeter of the rectangle. So clearly we need to solve these two relations together and to get the value of L and B. Then we can put the L and B value in this perimeter formula and we can find out the real answer. So what we can do is we can use some mathematical formulas rather to calculate that. So we have got L square plus B square and LB. So if we use the formula of L plus B whole square, what is L plus B whole square? It's L square plus B square plus 2LB. This is the formula related as A plus B whole square is A square plus B square plus 2AB. And if we go by this, then obviously we have got L square plus B square with us. So let's put the value of that. That is 41 plus obviously we have got the value of LB also. So it's going to be 2 into 20 like that. So L plus B whole square is coming out to be 41 plus 40, which is nothing but 81. That is what is L plus B whole square received. So if L plus B whole square is 81, then we can say L plus B value will be root 81. That is nothing but 9. Now we can use this L plus B value in our perimeter formula. If we do it, the perimeter comes out to be twice of 9, that is nothing but 18 meter. So that becomes the right answer for us. 18 centimeter rather, the units are in centimeter. So the perimeter value becomes 18 centimeter, which is available in option number A, becomes the right answer. Now he says, a lotus is seen 5 centimeter above the water level of a lake. With the onset of the wind, it sinks in the water 10 centimeter away from its place. How deep is the water in that place? So we need to first of all create the diagram of it to understand what is the situation. So he says a lotus is seen 5 centimeter above the water level. So let's say this is the water level and the lotus is seen 5 centimeter above. So let's mark it here. This is 5 centimeter. Okay. Then he says with the onset of wind, it sinks in the water 10 centimeter away. Okay, but it seems to have sinking in the water 10 centimeter away from its foot. So let's go 10 centimeter away from its foot. If we go like this and mark as 10 centimeters, so this is the point where it is looking like to be sinking. Okay, 10 centimeter away from the foot of the where the lotus is located. Now this is the first thing. Obviously this will be a 90 degree. Okay, this will be a 90 degree. So then he says how deep is the water in that place. So we need to know how deep it is at this place. So this, let's say this is that particular depth. Let us mark these numbers. This is A, let's say this is B, let's say this is C, and let's say this is D. So we are supposed to mark this depth. Let's say this depth is X. Okay, so we are supposed to find out what is this depth value. Okay, so you can clearly see if the depth value is X and the height of the lotus is 5. So clearly if you join, and the lotus is looking like to be sinking at the point C, so this very length will be nothing but the X plus 5 centimeter only. This very length will be nothing but X plus 5 centimeter only. That is the sum of the depth and the actual height. Okay, so that's what we have marked here. X plus 5 is this. We can join B and C as well. So this is what is the diagram. Obviously this is also 90 degree. This is what is the diagram of the question given to us. Now we are supposed to find out X in this. We are supposed to find out the depth. So we can relate it by a right angle triangle situation where we have got X, 10 and X plus 5 as 3 sides. So if we use the Pythagoras theorem, then we can in triangle ACD, we can clearly say CD square is equal to AD square plus AC square. If we put on the values, then your X plus 5 whole square is equal to AD value is X square plus AC square is 10 square. Okay, so if we solve this particular equation, we can obviously clear the value of X. So let us open X plus Y whole square using the formula A square plus B square plus 2AB. So it's going to be A square plus B square plus 2 into X into 5 is equal to X square plus 10 square, that is 100. The X square and X square get cancelled on both the sides. What we are left out with is 25 plus 10X is equal to 100. Then 10X value comes out to be 100 minus 25, that is 75, and X value comes out to be 7.5 centimeters. So that is the width, that is the depth he was asking for, how deep it is inside the water. So answer has come out to be 7.5 centimeter. It is available in option number B, becomes the right answer. Now he says a rectangular area having length 30 meter, breadth 22 meter is bounded by a series of trees. Okay, so the length has to be created as 30 and the breadth has to be created as 22 meter. Okay, so this is how it is. The rectangular portion is marked like this. The distance between two trees 1 centimeter. So this is marked by trees only. So one tree and another tree has got a distance of 1 meter in between, and this is how the trees are planted. This is how the trees are planted. Okay, this is how the trees are planted like this. Now he says, how many number of trees could be planted? So this question can be easily answered by a very simple formula. Okay, you want to create a length of 30 meter, you want to create a breadth of 22 meter. So clearly required number of trees can be directly found out by, there's a formula, twice of length plus breadth divided by number of trees, divided by gap between trees, This is the very simple formula which can be used to find out such situation. Whenever a rectangular area has to get bounded by trees with a gap maintained in between them, and the gap is same, then we can find out how many trees to be planted to create this much dimensions rectangular park. The formula is required number of trees equal to twice of L plus B divided by gap between the trees. If we use this formula, we're going to get to the number of trees as twice of length is 30, breadth is 22 divided by gap between trees, how much is 1 meter. So if we solve this, this comes out to be 30 plus 22 is 52. So it's 2 into 52 divided by 1, which is nothing but 104. So that many trees will be actually required to be planted so that the length of 30 and breadth of 22 can be created. Let's see where this is available. It is available in option number B. So becomes the right answer. Now he says, if the perimeter of an equilateral triangle is 72 centimeter, its area will be. Okay. So there's an equilateral triangle. Okay, let's create the equilateral triangle. Equilateral triangle is a triangle where all the sides are completely equal to each other. He says the perimeter is 72 centimeter. So let's say the sides are x, x, and x. So we can clearly say x plus x plus x is equal to 72 centimeter. The perimeter is nothing but sum of the sides of the sides of the triangle. So it's clearly becoming 3x is equal to 72 centimeter, from where we can find out the side length as x equal to 72 by 3, which is nothing but 24 centimeter. So each side is actually 24 centimeter long. This is what we have got. Now he wants us to find out its area. So area can be easily calculated. Area of an equilateral triangle, there is a special formula for area of an equilateral triangle, and that can be written as area of an equilateral triangle is nothing but root 3 by 4 into side square. Root 3 by 4 into side square. This is the formula of the equilateral triangle. We have got the side value as 24. We can put this into the variable called as side. So the area will come out to be root 3 by 4 into the side value is 24. So it's 24 square like this. Okay, we can solve this further. So area is equal to root 3 by 4 into 24 into 24. We can cut this by any 4. 4 6 ja 24. So ultimately it comes out to be 24 into 6 into root 3. That is nothing but 24 into 6 is nothing but 144. So it's going to be 144 root 3, and area has got a unit of square, so it has to be centimeter square. So that is the area, 144 root 3 centimeter square. Let's see where it is available. It's available in option number A, so it becomes the right answer there itself.